Welcome to another episode of Today and Tomorrow. Today we're going to talk about the invisible engine room of the digital age. Every time you send a message, stream a film, or ask an AI a question, something happens that almost none of us ever thinks about. Somewhere in a fast, windowless building, thousands of computers spring into action. And they get hot, astonishingly hot. So hot that keeping them cool now swallows up staggering amounts of electricity and water. We like to call it the cloud. And as thought it were weightless. The reality is rather more earthbound. And here's the question at the heart of today's conversation. What if the way we've cooled those machines for the last 50 years has been fundamentally wrong? What if the answer wasn't more air conditioning, more fans, more noise, but something almost counterintuitively? What if you could take those computers and simply submerge them? What I really mean with this, we're going to talk about in a second. But first of all, I'm very glad that I'm not alone here today. So, Dieter, how are you?
Oh, I'm fine. And always, after giving you a hard time and see you so joyful again, I'm really pleased that we managed once more again. I'm not going into detail now, but of course, energy consumption and data centers is one of the literally burning problems of today's world. And when you see that in the US, more and more data centers, the construction of new data centers has to be canceled because neighbors fearing the energy prices they are having because there's a tremendous energy shortage. And there's this one project of this one investor in Utah. He wants to have build data centers on a valley the size of Manhattan, and this would use up about double the energy consumption of the entire state, and most of it goes into cooling down. I'm not talking about if it makes sense to build such huge data center conglomerates. A
It
decentralized
would be a whole
structure.
different episode to talk about this.
Yeah, and a total. That's as you say, it's a totally different episode. But I'm very glad that I met a few years ago Serge, who seems to have a solution. He was named by the ICU, when was it, 10 years ago or something like that, amongst the 1,000 companies that could save the world. I mean, that's a big statement. But the technology looks really very interesting. And so I'm really keen to get an update because I know you had your ups and downs, but now things seem to start. And that's right in the right moment when the demand for a solution like that seems to be very high.
So, Zach, it's really nice to have you here. In the beginning, would you like to introduce yourself to our listeners and viewers? Who are you?
Oof. So, um, I'm 62. I'm French. Nobody's perfect. I'm a college dropout, so I'm sorry, no triple PhD or anything that I'm joking all the time about it. Um, the why I am today, in fact, is the combination of many things. First of all, instead to learn chemistry at school, I learned electronics because of my dad. And then because of my dad, we built a house. Okay, well, my parents has been living until, unfortunately, my dad left us. And I learned at the time what is some things which I didn't know, but basically you need to isolate a building in order before to put electricity inside for the cooling or for the warming. And the change is that basically when your building is fully insulated, then obviously you lose way less energy, and you also produce less energy in order to obtain the same result, knowing that the equilibrium point, which is the 19 degrees, and 20 is always set as a human being because that's what as human we need. And when I created Immersion 4 at the time, which is now Oppo Venture, that's basically one of the fundamentals that I've been using before knowing this as a name. That name is exergy. And I found out to catch through a friend of mine that was said and Minister of Energy in Switzerland, who told me, Serge, that's what it is. And I have to say that that day was pretty emotional because I realized that, in fact, my dad, uh, former resistance, okay, during World War II, and I was working since 14 years old, building a house with his own hands, basically knew with his, let's say, his wood pen, okay, designing everything. That was totally right, because when we create the first, say, the heat pump to cool the house and to warm up the house, the people told us, you're not going to pay more than 2,500 French francs per year. Well, 45 years later, the bill never spent over 2,000 French francs. That's the reality. Even doesn't matter the increase of the price of anything. And in fact, based out of that concept, that was very simple. Why don't you collect the heat from the ground through liquid, convert it, I would say, to a pump, to a heat pump in the house, and then take the 14, 15 degrees you take from the ground and basically warm up, I would say, up to 5 or 6 degrees more in order to warm up your house. And that was basically the principle of the heat pump, which, by the way, exists in the beginning of time. So imagine if in the planet we are all using the same kind of system, we will be totally fine. There will be no issue with the crises as we know it. So back to my background, well, working since also the beginning of the computers, before internet, before anything, before the computer, in fact. Okay, starting, I would say, working for our company called Bull. Before that, it was Transac Alcatel, okay, which has been federating all the electronics from the French. And it's been 45 years now, damn it, I would say, in telecommunication industry and electronics. And I ended up to create Immersion 4 because I was working lately for a company called On International, okay, based out of Washington, D.C. And On was a trusted company from the US government, and they were answering at a time in 2013 the call from the White House talking about how to reduce energy consumption based on an outdated industrial business model. I answered that call. And when I was looking basically the way the energy is spent around the world, okay, you have 50%, which is transportation, 50% in the building, outside in ball mass. And when you look at the building, which building consumes the most of energy? Data center. And how the data center are cooled? It's an air circulation, it's an air scheme. Why do you want to use air, which is an insulator, instead using liquid, which is a thermal conductor? By the way, I have been coding electronics all my life, okay, and from microsystem to mini system and to big computer as the DPS-6 and DPS-66 from Bull, using air cool. When a maintenance, we didn't know any better. And I didn't know, to be honest with you, when I was at On International, I will think about this. And then out of that, things making progress. I'm starting, to like different type of liquid and how we can do that. And then we created our own liquid based on the synthetic liquid. And we create also our own design of the product, which has been basically after that linked to the creation of Immersion 4. Immersion 4, due to certain issues, okay, when bankrupt, okay, had been liquidated. And we are now restarting, okay, because everything is totally clear out. Okay, we are restarting, I would say, a new operation called Oppo Venture, with who we signed, I would say, some very strategic partnership lately, based on, I would say, using, I would say, the liquid to cool electronics. And for civilian market, for government market, as well as for military. And this is basically where my entire background, I would say, end up. I found in Immersion 4, the turn back to the fundamentals, cooling an electrical component or electronics component using liquid. So imagine, and I'm taking, I would say, of course, this is not an electronic component, but imagine this is an electronic component. When this electronic component is warm up in the air, basically is warming up, it's generating heat, is having, I would say, corrosion, oxidation, and is attracting dust, is consuming electricities, and because it's in the air, so automatically there is a difference of temperatures which creates humidity. So if you take the same electronics component and you dig this outside and you immerse this electronic component into the liquid, you don't have any of those problems. And when you know that to protect this electronics component, you need to have all the conventional coating, the chemicals layers on the top of the PCBs, plus the fire retardant called the brominated. Okay, you don't need any of those layers when you're into the liquid, because into the liquid, you don't have any of those problems. So basically, we solve sorry to say, we solve not only the problems related to, I would say, cooling the electronic itself, but also to the recycling of the electronics. Now there is another, I would say, big dog in the house that no one talk about it, is the energy consumption. To make this energy consumption, let's change this. Imagine this is a cup of champagne, not an electronic component. And are you drinking champagne? That's maybe too much to say, of course. So imagine this is the cup of champagne and we want to cool the champagne. What do? Are we going to be cooling the entire room where we are? Or are we going to just cool the champagne itself?
Let's step some steps back. Your approach is, as you just described, to immerse the electronics completely into a liquid. And to many, that sounds alarming at first. Water and electronics famously don't mix. How does this work without everything being destroyed? And Dieter,
well, let me just put in a little anecdote, because when we first were talking about this, Serge, or I went to a guy who is constructing data centers, and he is investing billions of euros just in a region. And I talked to him, and I told him about it, and he turned away from me, and that I really can't explain my clients they should put their servers into a liquid. And so this basically is, I think, a really strong problem in communications you need to solve in order to get the product out in the market. The prejudice and trying it out should be immense.
Well, this is when you create, I would say, the technology, which is a breakthrough, and but also a much needed migration path because of energy scarcity, because of use of natural resources. You don't have any really any other options. So you can continue to extend. You can do marketing message. My HVAC is consuming less, but come on, guys. The big problem is not really that. The big problem is, and last I was saying with the cup of champagne, and I'm back to my cup of champagne. If you cool that cup of champagne, trying to cool the entire room with an air circulation, we're going to be frozen to death before the champagne is going to be even chilled. If you cool the champagne itself, we're going to stay in bathing suit, and in no time the champagne is going to be cool and we're going to be fine. And that's the thing. Data center is an air scan, so it's an air circulation to be sure that somewhere in the rack an hotspot is going to be cooled enough. And this is where I would say the entire data center is designed for. This is why I would say high ceilings, raised floor, chemical fire suppressor, in-row, HVAC, crack, thrash, all I would say those air circulation system to be sure that this is going to be doing. And of course, all the fans and the noise and the dust system and so on and so forth. So there is an entire things to be sure that this little PCB from whoever is going to be cold enough. If you use that and you dunk that into the liquid, this liquid must be, of course, dielectric resistant, 58,000 volt, which is our case. You can be able to connect fiber optics, electricity and data cable in and out, okay, without any service interruptions, which is our case too. The liquid should be guaranteed for several decades, which is our case, 25 years, and doesn't evaporate and doesn't need to be changed. And except if it's contaminated, which is another reason, but otherwise, no need. So you change completely the game. And if I'm telling you in the same time that this liquid is not petroleum based, that's it. Now, why it is something strange? It is something strange because we don't have the habit, okay, and we see liquid electricity shock. That's what we think. Well, there is liquid for transformers, for many others, which are what we call dielectrics, meaning they have an electric resistance to any kind of electricity conductivity within to the liquid. On our side is 58,000 volt. So imagine PCB is 220 volt. So we are very far from any kind of degradation whatsoever. Now it's a mindset. And you said, Dieter, what you said is absolutely correct. We are part of the problems. I am part of the problems. I never thought about cooling electronic with liquid, okay, on my 20s, on 30s and 40s when I was, working in a maintenance, working in a launching company or working for Alcatel and for many others, okay. because of our Lucent technology, because that wasn't a concern. And of course, if you take, I will say, this electronics, immerse into the liquid in and out, okay, you will have liquid on your hand. Well, you just have to basically wash your hand and that's finished. You don't have any more issue. Plus, the liquid have no impact on the human being and biodiversity. So imagine now that using that liquid, you have no water consumption.
Mm-hmm.
Instead of the 1.8 liter DOD is saying that I will say per kilowatts there is 1.8 liter water consumption. For us is zero. We all know, as I will say, the CO2 and the greenhouse, I will say, generated by the data centers. For us is zero. Imagine today that you can basically have the cost of your data center from 10 to 12 million euro per megawatts, going down to 3 to 5 million per megawatts. And I'm talking at equivalent data center, a tier 4 data center, basically, to compare Apple to Apple, without referring to Apple, as we know. And in the same time, imagine that the construction time from 2 years goes down to 9 months.
Mm-hmm.
So we change completely the let's say the problematic of what is a data center. For us, a data center is 1.2 tons on the floor, 2.7 meters high, meaning any building can become a data center. You can distribute a data center within the city. And because it's a liquid to liquid exchange, you can reuse 100% of the heat generated by the electricity. So not like my dad, you have to dig to take the heat at 1.7 meters, okay, on the ground. You can basically use the heat collected from the IT load, okay, and basically reuse it within any building.
You talked about energy savings, no or zero water consumptions, no pollutants. That almost sounds too good to be true. And now I want to ask you the other side. What are the limits of the technology?
We create a system, in fact, which has been designed like an air-cooled rack, operate like an air-cooled rack, except that instead the rack to be vertical, we are horizontal. We have two pathways for the cable, data cable on one side, power cable on the other side, horizontally speaking. We have immersed compartment and we have dry compartment for the part of the electronics, okay, which doesn't need to be immersed, PDUs, switches, and those kind of things. And of course, the one will need to be immersed. Even switches need to be immersed, it goes straight into the liquid. We have no issue with that. And then basically we adjust our system called DTM, meaning dynamic thermal management system. Basically, the clients modified or adapt the temperatures the way they want it. He said, well, I want 20 degrees, or I want 23 degrees, or I want 25 or 30 or 40. Basically, put the temperatures you want, and the system automatically regulates itself to give you the right temperatures. Consumption of our system is 780 watts. It works on 220 volt, 6 amp. That's the reality. We have been, I will say, testing our product with many customers, British Telecom, SNCF, Etisalat, Korea Telecom, and the product delivers what it's supposed to deliver. We have been in contract with HP even before the company creation in 2017 at that time, okay? And now, of course, we are, let's say, completely, I would say, brand agnostic. We can work with anyone around the world, okay? As long as, okay, we can just be sure we can modify the electronics on the sense that emulate the fan, because as you know, no appliances start without the fan, and that's basically it. The rest we don't have any issues. Mechanically, we fixed everything which could be fixed.
And it works. I mentioned the British Telecom test before. That went very positive, you told me once. Maybe tell me a little bit more about what this testing was included and what can be done with it.
Oh yeah, well, basically we tested with them the Nokia, the biggest router in the planet, 7750. Okay, to straight immerse in the liquid. The product stay immersed in the liquid over 2 years. No issue at all. And we tested with different customers, Cisco. Before that, also on our side, it was Supermicro, it was HP. We have been also in HP at the time in their innovation center in Geneva. okay, since 2018. Okay, we had an MOU signed with them since 2017. Like I said, it was previously as Immersion 4. Okay, now as Oppo Venture, the product has evolved. Okay, on a big scale, and but the philosophy and remain exactly the same. We avoid as best as we can to be proprietary, and we made a system to be able to be installed by any movers in the planet, to be connected to liquid through dry disconnect. So basically, any plumbing companies can do that. And to be connected to electricity, well, guys, it's an electrical plug. You just have to plug it, and it works. And now I'm going to say something insane, absolutely insane. Data center is a big house to say energy must run at all time. This is key, because without energy is a disaster. Imagine today I'm taking my system and I'm taking directly at the electrical plug and I'm unplugging my system. Everything shut down. Sure, I'm replugging my system. Without any human interaction, my system restart. The IDTM system restart and goes back to the initial setup that the customer wanted. And you can do that as much as you want, always doing the same things. Plus now we design our system in order to be exchanged by modules. And in case if the customer now is worried about, oh, but if your system is working or not working, or what are my guarantee? Guys, we are renting our system. So the responsibility is on us. If there is any issue, it's on us. That means you will not pay us. That's simple as that.
We talk a lot about where you are at the moment, but let's step a little bit back from the idea to the reality. You already told us you work with innovation centers with some big companies. You had it early tested in labs of major IT companies. How important was that external stamp of approval before anyone would ever listen to you? How important was it to have this feedback?
So, like Dieter was mentioning, my God, putting electronics into the liquid, that was something's falling apart. That was the biggest breakthrough in it. And then after that is, well, it must be something's proprietary somewhere. And then you end up to be the design. And as you know, when you work with all those big guys, they have a way to operate. Sometimes you can give your product for free, but the cost to accommodate the new product into a network is so high because you need to retrain people, you need to adapt all the procedures and everything, that even if the product is free, no one is going to do that. By the way, Huawei, if you remember, faced the problems obviously on a big scale at the very beginning. We on our side, okay, you can basically manage and maintain and operate our system like an air-cooled rack. Exactly the same things. Server up, server down, server upside down, whatever you decided. Of course, it's into the liquid. So that's the change. Is now the liquid have to do something, because as you know, the market is very noisy. You hear a lot of things about a lot of liquid, and for whatever it is. At the end of the day, there is a process. The process is, do we have enough electricity to power, I would say, those IT load, those compute power? The answer is no. Now we are talking about, I would say, multi-gigawatt data center, like Dieter was mentioning earlier. Can we afford to have, I would say, more pollution and the use of water? Not really. So this needs to be solved. And we are all, I would say, walking around and making laws to say, well, use of water and then no pollution and so on and so forth. And the cost of electricity, just have to see what's happening here on the other side of the coast, because of the Strait of Hormuz is blocked. The energy price is skyrocketing. And of course, this is impacting directly the cost of electricity on data centers as well, anywhere around the world. So the best way to solve this energy crisis, and like I said, this is the cheapest energy in the world, is the first principle of the 4 pillars that we have. We had 4 pillars at the time, and they are still the same. No CO2 emission, no greenhouse emission, okay, reduce energy consumption, and ecology. On the ecology, the first things was eco-conservation. Eco-conservation is the cheapest energy you can save in the world. Why? Because it's the energy you don't consume. So imagine that you're saving 80% energy consumption on your data centers, and you're just using this energy to power the IT load, to power the compute, not to power the cooling. you change the game. And this is immediate energy available right away. So before thinking about any kind of replacement, why don't we go back to fundamentals using a thermal conductor vector, which is a liquid, to cool electronics like our cars, like our homes are heating up and cooling and cooled, okay, using, I would say, the liquid which is compatible with electronics. You save the problems. Problem is done.
Yeah, that means we now talked about the technology. We talked about the basic problems you will have to implement the technology in people's minds. So, but now, what are the concrete steps you are taking towards market introduction, and where are you in this process right now?
So now we just signed an agreement with the company where basically we're also changing, I will say, the materials we have. Okay, we have the PMMA, which is the ITU glass transparent. We're going to keep it. And now we are also, I will say, changing, I will say, the carbon fiber, and we're going to be replacing that with basalt, the basalt material. And why? Because it's stronger than steel, lighter than steel, cheaper than steel, and better than carbon fiber. And we just signed, I would say, the complete strategic agreement with a company called Basalt International. And we're even going way deeper now. So I would say that I will not say much for now, if you allow me to. And then basically we are, I would say, going to hit the market very strongly by the end of this year with product, knowing that our entire business model is based on circular economy. So basically, like HP did back in the time, okay, the HP way, building labs and production centers around the world. And we reduce the carbon footprint. We, I would say, mixed value and values together. And in the same time, okay, we answer two problematics which are key today for any nation in the world, which is data sovereignty and energy sovereignty. Energy sovereignty by reducing energy consumption, okay, and data sovereignty by having your data center at home, I'm sorry. So it's quite a game changer for many, many things. And yeah, and that's basically where we stand. And, we standardize our product, okay, in order to make it easy, easier to maintain, easier to be exchanged, either to evaluate. And we basically erased or eliminate, will be the better word, any kind of bottleneck we can have on technologies to welcome almost any kind of appliance, okay, as we know it.
Well, the technology has been around for a while now, and of course there was a little roller coaster in between, but you still have had partners and possible clients before. So are you starting from zero, or is there a certain base that you can build on? I would assume you have.
Well, the way we see the market is it's a little bit different than that. Imagine we are under, and without comparing ourselves to one of the best figure in this world is, which, for example, we take Elon Musk. Elon Musk, when he created the first electrical car, okay, he did another gigafactory, but he knew this is the path. This is the path where we should go. Of course, he had a bigger vision, but that's basically the path where he was going to. For us, when we create our DDM system, I said, well, this is the way we go. We need to use liquid in order to do that, and that was basically the same kind of path. Now it takes time, because when you add this electrical car, well, where are you going to be basically recharging the car? What is the battery you're going to be using? So there is many technology challenge that you overcome over time, and also the infrastructure has been built around in order to be able to ease the use of electrical cars. We're on the same path. Okay, we have our system. Our system is ready. Are the data center ready to adopt it? Until now, regarding what the competition is providing to the market, they were not. With us, the answer is yes, because we can literally be put in any data center, air-cooled, using any kind of technology, from full air-cooled rack to, sorry, I have somebody calling me. Apologize. So basically, where we can, sorry, okay. So basically, we can put our system in any air-cooled data center without disturbing the air scheme, okay, the air circulation system within this data center. Doesn't matter if it's fully air-cooled, if it's water cooling, if there is DLC, any kind of technology, we basically can interface our DTN system within any data center without modifying anything. So we become an evolution vector, a migration vector, solution for brand new data center. And due to the fact that we design it in order to have zero service interruption, okay, light out is the end game, but also from edge to hyperscale. So basically, we can address anything into the market. And if tomorrow we have one of the big guys, a GAFA, let's say a Google or Facebook or whoever, say, well, okay, guys, we'd like to partner with you. Our answer is not, well, we would like to sell you our product. Our answer will be, can we build the product together? We can make a factory together. We can accommodate your standard. This is why for us, when in 2019, ITU discovered, I would say, the technology Immersion 4, okay, we have been at the time the best use of ICT Global Excellence Award, because the biggest award we can ever get. And then since then, we have been leading, I would say, on the AI for Good, artificial intelligence for good program since 2019. It was a complete game changer. And if you look at from that time that we are talking about, 2026, we are now slowly moving forward. And now everybody is talking about immersive cooling. Well, the name of Immersion 4 has been created in 2017. So, and 4, but because of 4 pillars, because of 4 principles, because it was for the people, for your kids, for your family, for energy, for the planet, for everything. The 4 has a meaning. Of course, in Chinese, 4 is not a good number. Don't get me wrong. Okay, I'm not going to disclose the new name of Oppo Venture that we're going to make soon into the market. Okay, when we're going to be launching everything together. But that's the philosophy is exactly the same, and we just have to look at the way the market is. There is a time for market adoption, and then after that, there is different condition who trigger the speed to the go-to market. Doesn't matter how much money, how much effort you're making to the market. What is important for you is to be able to prove over time that your technology was the right one. And I think in that path, we proved that was the right one. By the way, before Immersion 4 was created at the very beginning, okay, we already had an MOU with HP. HP was already validating the technology in 2017 before, I would say, the creation of Immersion 4. And now, as we're starting as Oppo Venture, we find ourselves the same bunch of guys, okay, still motivated and still liking the technology, because in 2017, no one was talking about immersive cooling. Remember, leader, when we met together, he said, Serge, what the hell are you talking about? When people were looking at my server, going in and out into the request world, there were people who were laughing. Today, they said, that's the way to go. How can we do it? How can we make it? You don't go to any data center when there is not someone presenting some things immersed into the liquid. Well, make me smile personally, because I've been one of the first starting those kind of things, and that's the way to the market. We learn a lot. Okay, we're still learning a lot. We are still, I would say, looking how the system can be performed. How can we do it better? We know what we have. We understand clearly the advance that we have into the market. This is why also we have been always low profile on many ways. But it's going to be time, obviously, to get out on a big scale. Plus, okay, we overcoming every noise, because the market loves to make noise around of you when you create some things that some people want without really doing anything, but that's another story. And technology is here. Technology works. And we're the true founder of the immersive technology. So we know what we are talking about.
We talked about the past, we talked about the present. Now let's talk in a final question about the future. Where do you see your technology in 10, 20 years?
If I was dreaming about it, I would say no electronics should be without immersive cooling. None. Otherwise, for me, we are liars. We don't care about the e-waste. That means we will continue to have PCBs with all the chemicals layer making electronics non-recyclable, because at the end of the day, this is what we are talking about. Don't forget that 2 years earlier, 2 containers of the 3 leaving Europe were going with electronics to be recycled in Africa, meaning to be burned. By the way, when you burn, there is no borders. So we all smell the same things. And the most contaminated agent is the brominated. So that's what we do. So imagine that tomorrow you don't have all those chemicals. You're basically able to recycle your electronics where I would say where it is used. And in the same time, you stop digging the planet to look for all those materials because you have them on the recycling side that you can reuse with a very expensive process to do that. So that's number one. Number two is the energy consumption. Would be very nice to keep, I would say, the energy consumption to the humanity and to our needs instead of an AI. I know that people look at AI as the way for the future. It is the way for the future, but it is also important to understand, I would say, the cost of it. And not only on energy. What about on natural resources consumption? Talking about pollution emission and talking about water consumption. Well, on our side, we're keeping that for the biodiversity and the humanity. Because the big elephant in the house that no one is talking about, 2 years ago, we lost over 70% of our biodiversity. And that's the real challenge. Because without biodiversity, we are nothing. So I hope, because we have all the knowledge, because we are human, because artificial intelligence is nice, but intelligence is better for me, and common sense. True common sense, I do believe that if we use energy for what matter, if we use natural resources for what matter, we can arrive to a very old philosophy, which is, by the way, translated in Chinese by the yin and the yang. It's called harmony, the balance. If we balance energy consumption, natural resources, I would say, use, and understand that we must respect what we take for granted, which is the entire biodiversity, we can make this planet pretty good living place to be. Because, sorry guys, as much as I love Elon Musk or anybody there, but I don't want to live in Mars. First of all, my friends are not there. Second of all, even if you're giving me, if I'm getting a 10,000 square meters house in Mars, I cannot live today, and no one today can live only in France or in Germany or anywhere we are living without traveling somewhere. So are we going to live in 10,000 square meters for the rest of our life? I'm pretty sure no. So we can make, I would say, this planet, I would say, a pretty damn good place to live. And what about living a paradise that we create in that planet? Why don't we say planet Earth first, and then looking to conquer some other spaces with maybe other technology like space-time that a dear friend of mine called Nassim Al is working on for years. And because we all know that, I would say, the fuel is not going to be the one, taking us to space, to any other planet. So we need to use something else. And that's my wish. My wish, I would say, is humanity will not take about some intelligence, because I think there is still a lot of intelligence in humanity, but just maybe to take some common sense. And that will be pretty damn good in order to use energy, to use our competencies, and to consume based on our real needs, what we want to do and where we want to live. And that will be my wish. Because, I'm 62. So, I'm close from the exit than from the entrance. And I'm ashamed to see that we have seen so many technological revolution, and we can still see this massive gap between the decision maker and between what the technology will allow to do just by common sense. So my wish is, if we get common sense, I think we will all win. Otherwise, we're all going to lose. So let's hope immersive is going to be everywhere, not for my sake, but for the sake of everybody. And I know I will have hundreds of competitors, and this is okay. This is normal because the market is massive. So we don't have the pretension to see, we're going to be the one. But we know that we are the leaders because we know I've been, I would say, one of the first. I want to say the first, but close by. And it's going to be fun, I would say, to have that discussion, I would say, around a beer or cup of champagne in 10 or 20 years from now. I say, hey, do you remember the interview we had at the time? Here we are.
Well, so everything is depending on common sense, but common sense is something that seems to accomplish very difficult at the time being. So let's see what happens to your new venture and to immersive cooling, because this could be a perfect step forward, I would say.
Well, like there is a song saying, there is an art rock group saying, well, never stop believing. I think it was Deep Purple or something like that saying those kind of song. And the key for everything is resilience, never giving up and never stop believing. So
Thank you. You see my resilience book in the background. That's exactly what I'm preaching all the time.
I know, I know. And this is why I was said I'm breaking that because resilience is everything. And but when as much as we can be resilient and we can be stubborn and wanting to make it happen, never stop learning, being constant learner and looking what could be the new and how can we make it happen on the best way. And at the end of the day, if we create the product, because this is all about the product, we create a product and the market wants the market is going to be sold. So this is not even a question of price or anything. Okay. Now, this is something that we all need. This is not even an option. We know this is some things that we need. Okay. That's a must have. Okay, for a lot of reasons. Compute is not going to stop. We are talking about zettabyte after zettabyte, and this is increasing as crazy. We just have to see all the new announcements, everything. NVIDIA is making product to the market. As soon as the new product goes to the market, it's already obsolete. That's what it is. So eating is important. And by the way, so much heat that we can get for ourselves. Could you imagine? We don't have to burn gas. We just reuse the heat from the IT load connecting to an IT to the heat network in town, okay, in order to warm up the house. Same principle that the geothermal. Back to the fundamentals, guys. Physics law. Our solution responds and fit with all the physics law. I can send you the white paper I wrote in that matter.
That would be lovely. And with the message of never stop learning, we are going to leave this episode now. Such thank you very much for your insights and all for all the wonderful ideas. And if you take one thing from today, let it be this. The next time someone mentions the cloud, picture the building, picture the heat, picture the water, the electricity, and remember what Serge said, that none of it is inevitable. Someone somewhere is questioning whether it has to be that way at all. And as we heard, it works. So that's what really is. Sorry, I start over. Um, so if you take one thing from today, let it be this. The next time someone mentions the cloud, picture the building, picture the heat, picture the water, picture the electricity, and then remember Serge. Someone somewhere is questioning whether it has to be that way at all. And this is what the show is all about. Not just the next clever idea, but the willingness to ask the awkward but also the right questions in the first place. And I'm glad that you asked this question and it works out. So, from my side, as always, the final words go to Dieter. I say thank you for your time. I will say goodbye later on again. But, Dieter, your final takeaways.
When we started this podcast, we had a claim, and this was we lead you to the future. And it's always hard to fulfill a promise like that. But in this episode, I had the feeling we really came close to that claim and we moved a little step further into the future.
And with this, I say thank you to all our listeners and viewers. This was Today and Tomorrow for this episode. We hope you learned something again for your future. If you liked this episode, please follow us and subscribe. We will hear or see each other next time. And with this, a wonderful goodbye and ciao.